Chapter 7 Sample Problem 3 For link OA in the horizontal position shown, determine the force P on the sliding collar which will prevent OA from rotating under the action of the couple M. Neglect the mass of the moving part. At first we should obtain an expression for the position of B and also an expression for the rotation of M as the dimension in the picture. At first consider the picture again here. We have a dimension, a specific dimension. If we assume that the point A with the primary position and point A and also point B with the primary position here, and a little change in the direction of A to A prime. The link B should be changed in the direction B prime. This is delta y and this is delta x according to the dimensions here. An expression for delta y, we have a little angle here. Delta y equals to delta theta multiplied to A, or delta y A delta theta. For the position of delta x, we have this relation x2 plus y2 equals to b squared. It is dimension constraint, so 2x delta x plus 2y delta y equals to 0. So delta x equals to minus y on x delta y. And substitution this relation delta x equals to y on x A delta theta. The principle of virtual work say that delta u equals to 0 p delta x plus m delta theta equals to 0 p delta x obtained as this relation. A delta theta plus m delta theta equals to 0. P can be obtained and is eliminating the delta theta and x m on y a. So P is mx on ya, or y is constant or not. To the center of the OA, y is constant, mx on HA, the final answer.